Alright, so in this video, we will be discussing May-June 2025, paper 3-1 for pure mathematics 3. So let's have a look for the first question. They want us to sketch the graph of y equals to modulus 2x minus 3. Alright, so when you're having a modulus linear function, this is a modulus function, right? And then inside is a linear function. So when you want to draw any modulus linear function, basically the shape will be a U shape, will be a V shape, right? And usually how am I going to draw is, I try to draw the original graph first without the modulus, right? That means I'm having this value, this equation, I will let y equals to 0, then the value of x that I have is actually 3 over 2. And after that, if I let x equals to 0, then my value of y will be equals to negative 3, right? Okay, then I will try to sketch it out. Okay, so for me, what I do is like, I try to find out the ratio here. So I'm having 3 over 2, then times 2 is a 3. Then I might have 3 over 2 times 3 here, times 2 here is negative 3. Then this one is a positive 3. Okay, for me personally, I will try to draw the original graph first, where I'm having the first value, the x-intercept is 3 over 2. So 3 over 2 means this particular point. And then for y-intercept, it is negative 3. So this is the original part here. Then if I try to join my diagram together, my 2 points together, it will look something like this. Okay, so you connect the 2 points by using the by using what? By using a ruler. Okay, yeah, so it should be a straight line now, right? Okay, so let's draw a nice straight line here. My line will not be too perfect, very perfect, but for you yourself, please use a ruler to draw it out. Okay, then after that, because we put the modular sign, right? So when I put the modular sign, that means the whole graph should be a positive value. What does it mean? It means that for this negative 3 value, you have to reflect it up, become positive. So when you want to reflect it up, become positive, that means you're having a positive 3 here. All right, and the whole part under the x-axis, you have to reflect it become positive as well. So you reflect it through the x-axis, your graph eventually you will become something like this. Okay, so the green color part that I show you here is basically the reflected graph, okay, from the negative part or below the x-axis. I'm sorry, I can't draw it nicely. Let me try to draw it as nice as possible. Okay, assuming this is a straight line, right? And your final graph will look something like this. It is a V shape. Okay, where the green color part is the reflected part of the graph when I put the modular sign, because when you put modular sign into any function, it should be always positive. Okay, all right, and then for your information, to be more detailed, right, if you want it to be more detailed, then you have to know that this reflected graph, when I want to write the particular equation, it should be negative 2x over 3, 2x minus 3, because I reflect it up. So it seems like it is something like you multiply a negative value to make it become positive. Then this one, this part of the equation is the original graph, where it is actually 2x minus 3. Alright, so this is basically how I draw the diagram with the modular sign. I will draw the original graph first, then I reflect the negative part become positive. Yeah, so this is the answer for part 1, question 1, part A. Let's continue to part number B. They want us to solve this inequality 3x minus 1 smaller than 2x minus 3. Alright, and since they asked us to draw the diagram for modulus function in part A already, I already have the diagram for this one. So maybe for this question, it will be convenient where you try to draw another line where you are having 3x minus 1. If you try to draw the line y equals to 3x minus 1, right? Same thing happened here. You let y equals to 0. Then your value of x is 1 over 3. Then when you let x equals to 0, your y value will be negative 1. So if I try to plot these 2 points on my diagram just now, then how will it look like? Okay, so let's have a try. I'm having 1 over 3, 0, then 0, negative 1. 0, negative 5 might be somewhere here. 1.5, right? So the 1 should be somewhere here, negative 1. Then 1 over 3 should be somewhere here. Then we try to join the line together. Okay, so this is how my graph look like. Okay, all right. So if you want to use the diagram to help you a little bit, right, you have to make sure that the scale that you are using or ratio that you are using is the correct ratio or the scale. If not, it might actually a misleading graph. They might give you a wrong answer, a wrong idea about the whole solution. Okay, so I'm having y equals to 3x minus 1. And you can see that if I try to extend the whole graph here, no matter how I draw the graph, I only have one intersection point, which is this one. So to solve this intersection point, I need to solve the equation 3x minus 1 equals to, it intersect with the reflected part of the graph. So you can find out the intersection point by using 3x minus 1 equals to negative 2x minus 1. Alright, so this diagram actually helped me to figure out in an easier way what is the intersection point, and then which are the two graph or two equations that I have to use to find the intersection point, right? Yeah, so from graph, I know that my intersection point is these two equations. Therefore, I solve this equation here, right? So let's continue from here. I will be having 3x minus 1 equals to negative 2x minus 3. Did I write something wrong just now? Oh, sorry. This one should be 2x minus 3. Right, so I try to I try to solve the x, the equation for the x. And the value of x that I get is actually 4 over 5. And now I need to decide which part of the graph I'm having the 3x minus 1 smaller than modulus 2x minus 3. Okay, so you scroll up again. You try to separate your graph into two parts, before and also after the intersection point. Then you try to compare and see which part of the graph will give you the black color line is below the V shape. So you can see that this part of the graph will show you the black color line, which is 3x minus 1, is under or below the V-shaped graph, right, for this part. Because if you try to observe for the right-hand side one, you will see that the black color graph is above the V-shape. So when black color graph above the V-shape means that your 3x minus 1 is greater than this diagram, this modulus graph. Okay, then we are looking for the smaller one, right? Therefore, the highlighted part will be the area where your 3x minus 1 is smaller than the V-shaped graph or the modulus graph. All right, therefore, to write out the answer, I know that it should be smaller, the x should be smaller than 4 over 5 because this line, x coordinate is 4 over 5. So after you find the intersection point, don't forget to write out the answer according to the graph that you observe, and you're having smaller than 4 over 5 here. Right? So this is the method where we are trying to use the graph or the diagram that we draw to figure out the answer. But of course, you need to find the intersection point first. Okay? That's another method where if you don't want to use the diagram or use the graph that you draw, but you purely looking at the inequality, then how can we solve it? All right. So for method number 2, I will show it to you here. For the 3x minus 1, okay, smaller than modulus 2x minus 3, right? For this modulus function, there are two parts. One part is non-reflected one, 2x minus 3. The other part is the reflected part, so it will be negative 2x minus 3. Okay, now I try to solve this inequality first, solve the equation first, where I have 3x minus 1 equals to 2x minus 3. Then 3x minus 1 equals to negative 2x minus 3. Alright, then after that, what should I do here is I try to solve the equation as well. I will get two values for the x. Okay, so the first value of x that I get is negative 2. Then for the second value of x that I try to solve is actually 4 over 5, like what we showed just now. Okay, then after you get two intersection point, the coordinate for the two intersection point, you have to check part by part which is the answer that you want to accept. So I'm having x equals to negative 2, I have value of 4 over 5. And now to check for my final answer, I double check my answer part by part, yeah. So I separate into 3 different parts here. Alright, so I hope that you can see it. This is part number 1, part number 2, and also part number 3. Okay, so for this part, it is belongs to x smaller than negative 2 lah. So you let any value that is smaller than negative 2 and you substitute into your inequality. So as example, I substitute x equals to negative 3. So negative 3, substitute into the inequality. Negative 3 times 3, you have negative 9, minus 1, you have negative 10. Then smaller than modulus of negative 3, substitute inside, negative 6 minus 3, you have negative 9. So you have modulus negative 9 here. If you simplify the equation, it will become 10 smaller than a positive 9. So you ask yourself, is this a correct inequality or not? So the answer is yes, right? So that means this is the part with the answer, with the correct answer for this inequality if I substitute the x smaller than negative 2. Then for the second part also, I try to substitute some value of x which is between negative 2 until 4 over 5. So what should you do it? You should put it as 0, one of the example. So if I substitute x equals to 0 into the inequality, then I'll be having negative 1 smaller than modulus of negative 3. And I will get negative 1 smaller than positive 3. And this is also a correct inequality. So that means this part of the answer is still correct. And next one, it will be x equals to 1, let's say. Substitute x equals to 1 into my inequality. So I'm having 6 minus 1, which is a 5, smaller than modulus of negative 1. So 5 smaller than 1. And very obvious, this is a wrong part of the answer, right? So according to the answer that I checked part by part here, basically you can see that the answer below the value x equals to 4 over 5 will be the correct, will give you a correct inequality. Therefore, from here you will have x smaller than 4 over 5. So there are two possible methods here. The first method is by looking or observe on the diagram. Then the second part here is after you get the intersection point, then you try to figure out which part of it is correct. But from here you can see also, right, without the looking at the graph, you'll get two coordinates of the x. Where if you are using the graph, you can see that there's only one intersection point, which means that this negative 2, the intersection point does not exist, basically. Alright. But after you check it part by part, you realize that the overall answer is x smaller than 4 over 5. Alright, so this is how we solve the question number 1. Question number 2. We are given this equation and we want to find Q in terms of P. Okay, this equation basically we are having ln and also some pure number here, right? So to rephrase Q in terms of P, maybe the first step is we need to try and get rid of all the ln. So to combine the ln and also get rid of all the ln, there are a few important properties that we need to know. Alright, so there are a few important rules. The first one is if you're having n ln x, basically you can change it back, become the constant in front, you can change it back, become the power, where it will become ln x power n. Okay, then after that, if you are having ln x plus ln y, what can you do is that you can combine them back, become ln x multiplied with the y. How about if let's say I have a minus one, so ln x minus ln y, you will have this ln x over y. Then lastly, one more important formula that we need to know is if you're having ln x equals to a, if you want to get rid of the ln, you want to bring the ln over, right? And the ln is basically log e, log base e. So when you want to get rid of the ln here, you have to bring the base e, go over to the right hand side, and it will become x equals to e power a. These are a few important formula that we are going to use to make our equation here become the equation with Q in terms of P. So let us start. Let me copy down the equation first. Okay, so for the first step, because I can see that there are a few terms in ln on the left, so I want to combine all of them become one single ln. Before I do that, I will apply the first rule first, where I try to bring all the constant go back become the power. So for the first term, 2 ln p will become ln p squared. So I'm using the first rule here, right, that I list out just now. Then for the second term, nothing there, so I just copy them. Then for the third one, I'm having half, right? So the half, I bring it back, become q plus 1 power half. The half in front, I bring it back, become the power. The 3 is a constant on the right, I don't touch it yet. Alright, so you can see that we are having 3 terms of ln here. This one, second term, and also the third term. I want to combine all these ln become 1. So for the first 2 terms here, ln p squared plus ln p minus 1, I'm using the rule number 2, where I want to combine them become 1 ln, because it is the plus, right? Both are the plus. So you'll be having p squared multiplied with p minus 1. And after that, for the third term, you're having a negative. So when you're having a negative and you want to combine them become 1 ln, you have to bring the y go down, become denominator. So this particular term here will become denominator. I will be having q plus 1 power half. Then it is equals to 3. Okay, then before you can keep your q on the left hand side alone, you have to get rid of the ln first. So how can I get rid of the ln? We are going to use the rule number 4 here, where you bring the e over and the number on the right will become the power. And if I try to apply this in our question here, this is what I will get. Equals to e power 3. Okay, then now my final aim is to keep all the number and everything to the right, then keep only the q on the left. Okay, so let us start from here. Let's continue from here. I will have p squared, then p minus 1, or maybe I put it in this way first. I try to bring the e power 3 down first, become the denominator. And then the whole denominator with the q, I bring it to the other side. Okay, so if I try to rephrase it again, I'll be having p squared, then p minus 1, then e power negative 3, right? Because the denominator with the power, when you want to bring out the power, become negative. Correct or not? Now, next step is I want to get rid of this square root. So to get rid of the square root, the whole equation, you have to square them. When you square p squared, you will have p power 4. Then the p minus 1 bracket will become a 2. Then e power negative 3, power times 2 become negative 6. Then after that, I want to bring the 1 over, and eventually this is what I get. I'll be having p power 4, p minus 1 square, then e power negative 6 minus the 1. And this is what I get. I try to express q in terms of p. Right, and maybe we can have a look whether do they request any specific pattern or not for our final answer. So they didn't mention anything, right? They just say q in terms of p. So I will keep this as my final answer. And this is how we solve question number. Alright, so let's discuss question number 3. We are having a complex number z when it is like this and it is real. So the real means that your complex number, after you rationalize it, you'll be having a plus 0i. There will be a 0 at the imaginary part. And after that, the modular z is equals to square root 17. Give your answer in the form of z equals to x plus yi, where x and y are real. Right. So to get the complex number z, we have to use the information given by the question and try to form equation and solve them. Right. Okay, so just a reminder, or just to recall, right, we are having x equals to z equals to x plus yi. Alright, what's the modular z? What's the formula for modular z here? Magnitude of the z, so basically it is the square root of x squared plus y squared. Alright, so we are going to apply it here. So
modulus z is equals to square root 17. So I think it's quite straightforward. You'll be having x squared plus y squared square root equals to square root 17. And from here, I form the first equation, x squared plus y squared equals to 17. Okay, I have done with the first equation or information given and form the first equation here. Then let's continue to the second equation. So to form the second equation, I want to use this one. Okay, so I know that z plus 5i over z minus 5 is a real is a real number, right? So we are going to continue from here. I cannot compare this directly, so what I do is like I try to make the denominator disappear. Okay, so maybe before that, I just try to substitute the z into fraction first and see what do we get first. Okay, so z is x plus 5i, right? So I substitute into the fraction. Okay, then I group them in the form of real and the real part. Okay, so from here you can see that, oh, I have a fraction with denominator with the I. So to get rid of the denominator with the complex number I, we will need to rationalize it by using the conjugate of denominator. Okay, so multiply the conjugate of denominator. What do we have here? So we are having x minus 5 minus yi. Same thing happen on top, x minus 5 then minus yi. Alright, so please expand and simplify the bracket carefully to get rid of the I at the denominator part. Okay, so this one a bit tedious, yeah. Right, so you just need to make sure that you expand it very, very carefully. I y square minus y square I square, so it becomes positive y square. So maybe from here to this step, you have to take note that you will be using this y square, sorry, not y square, is I square. So I square is equals to negative 1. Alright, so I have to simplify the I square in your expansion here, right? Okay, then I'm having this on top. Okay, I made another careless mistake here, sorry. Minus or plus y plus 5, then I square. Okay, now I simplify, become positive. Okay, so this one looks so complicated, right? Then again, because I want to make it, I want to find out the, I want to compare with a plus 0i because of the fraction here is a real number. So what I do is like I separate the real part and the imaginary part. This is the real part without the I one. Okay, then divided by this. Then after that, I group the imaginary part. So imaginary part, I'm having x plus 5, y minus 5, minus xy. Okay, then I will be having x minus 5 squared plus y squared. So you can see that I'm having real part and also this is the imaginary part. Okay, then now because of we are having the information where it is the real, so we want to compare it with something like this. So we want to compare it with a plus 0i. So the real part is a, this one. Okay, then the imaginary part is this one. So I want to form one equation from here. Alright, so I let the imaginary part equals to 0 because it is equals to 0i, right? So we compare it with the 0. So see what do we have. Okay, then equals to 0, right? So you'll be having x minus 5, y plus 5, minus xy equals to 0. Okay, so please further simplify this equation and see what do we get again. So xy plus 5x minus 5y minus 25. So I have 5, then x minus y equals to 25. Because I think these two terms can be simplified. And eventually you'll be having the equation here where x minus y equals to 5. And this is my second equation. Right? Then after that, if you try to solve first equation and second equation simultaneously, basically you can get the value for x and y already, no? Right. Okay, so this method, we are using the information where we know the imaginary part is equals to 0. Therefore, I try to rationalize everything, then I get the imaginary part equals to 0 here. So I compare it with the 0 for the imaginary part, and you form the second equation. And a lot of students might find out that, oh, this is quite tedious, right? Because you have so many unknown here, alright, so long. Looks very complicated. Alright, so if let's say you don't like this method, okay, to get the second equation, there's another option here. Okay, so option number 2, I will write it here. Okay, so for option number 2, we are still using the same information where we know that, okay, we know that the z plus 5i over z minus 5 is real. Okay, so that means I know that when I write it out in the complex number form, this one, after you simplify, it will be equals to k plus 0i, or a plus 0i also can, just like what we did just now, right? So you can let it equals to k plus 0i, or it is equals to a plus 0i, as long as the value here is a real. So you must have the 0i, which is the, how to say, it will be the 0 imaginary part. Okay, and then, so it is equals to k, in short, because it is real, so there's no imaginary part, right? So it will be equals to k, which is a number that we don't know. Okay, but if let's say I try to also substitute the x and y into my equation here, okay, so maybe I try to get rid of the denominator, I bring it to the other side. So x plus yi plus 5i equals to k, then z minus 5. So the z here I replace it by using x plus yi. Okay, then again, I try to group imaginary part together with imaginary part on the left. Then same thing happen for the right hand side. I will keep in a real part with the real part, imaginary part with the imaginary part. Okay, then after that, what I did is I will try to compare real part with the real part, and also imaginary part with the imaginary part. When I compare the real part with the real part, this is a real part, right? Then this is also the real part, right? Okay, so from here, what do I get? So I will be having x equals to k, then x minus 5. So I get the equation k equals to x over x minus 5. Okay, then after that, I try to compare the imaginary part with the imaginary part as well. Okay, so what do I get from here? I will be having y plus 5 equals to ky. So what's the k here? K will be equals to y plus 5 over the y. Okay, then from here you know that this value of k should be the same. Alright, So what I do is I try to compare them also. So x divided by x minus y equals to y plus y divided by the y. Simplify this equation. Yeah, so basically you can see that we actually also get the same equation because you can simplify xy and xy. Then after that, what do you get here is you'll be having 5, then x minus y equals to 25. So this is how you get a second equation. Basically, it's the same like what we did just now, what we get just now. Alright, just that this method is another option. Alright, so some students, if they don't like to rationalize the complex number or rationalize something that's so complicated or so tedious, then basically you can apply this if you want. Alright, so you can see that the equation here that we get is the same. Okay, alright. So after now you already get the two equations here, right? X squared plus y squared equals to 17 and also x minus 5 equals to 5. So let's continue and try to solve it. Alright, so I rewrite my equation again. I'm having x squared plus y squared equals to 17. This is my first equation. Just now my second equation is x minus y equals to 5, right? Equals to 5. So I try to make 5 plus y. Okay, then sub 1 into 2. Sub 2 into 1. I think to solve this simultaneously should be no problem for you. Okay, maybe the main trouble is to form the two equations to be used in the in solving it. Alright. Okay, so expand it. You'll get a quadratic equation in y. Factorize. And you'll get the two value for the y here. Okay, y equals to -4 and also y equals to -1. Then try to substitute it back into the second equation. So second equation means x equals to 5 plus y, right? So x equals to 5 minus 4 and your x will be equals to 1. Then for this particular answer, x equals to 5 minus 1. So x equals to 4. Okay, then of course we want to simplify our answer into the complex number form, right? Therefore, the value of z, the complex number z can be 1 minus 4i. Then another answer is z equals to 4 minus I. Alright, so yeah, so basically this is how we solve question number 3. Okay, so question number 4. We are given the parametric equation of the curve and this is what we have. Then they want us to find the equation of the tangent to the curve. Tangent, then at the point. Give your answer in the form of y equals to mx plus c, where m and c are exact. So highlight the keyword exact. Okay, so for this question, it wants to form the linear equation, which is the equation of the tangent. Right. Then you have to remember every time when you want to form any linear equation, we need to have two information. The first one is the gradient. What's the gradient of the dy dx? What's the gradient of the tangent? So the gradient of tangent, we should know that it is equals to dy dx. And after that, I also need the passing point to form the equation. So this is the passing point for the line. Alright, I already have the passing point. I need to find out the gradient of tangent first before I can form the equation. Okay, then how are we going to find the dy dx? since they give us the parametric equation, right? X in terms of t, y is also in terms of t. To get the dy dx, you basically have to apply chain rule. So I list out here the formula that we are going to apply later. So to get dy dx, you have to apply chain rule, dy dt and dx dt. Then to differentiate all the terms inside here, basically it involves how to differentiate e power fx. So you copy back the e power fx, differentiate the power, and you put it in front, f prime x, right? How are we going to differentiate tangent? So to differentiate the tangent, it will be equals to secant square. Then how to differentiate a function with a power n? You put the power in front, copy the bracket power minus 1, then you differentiate the thing inside the bracket, you get f prime x. All these are some very basic differentiation technique or formula that you need to know before you can answer this question, right? And let's start. Okay, so we are having x equals to e tangent t. Then dx dt is copy the e power tangent t, then differentiate the tangent t. Differentiate tangent, you have secant square, right? So I'll be having secant square here. So secant square t, then e tangent t. For the y, I'm having y equals to 3 tangent square t. So I will write it as tangent t with a square outside. So it is actually the bracket with a power outside. So to differentiate tangent t square, I put the 2 in front, become the 6. Then copy the bracket. And after that, differentiate the thing inside the bracket. Differentiate tangent t, what do you get? You are getting secant square t. Alright. Then after that, if I want to get the gradient of tangent, I need to apply chain rule, right? But before that, I want to know what is the value that I have for dy dt and also the value for the dx dt. Okay, then how can I get the value? For the dy dt and dx dt, I need t, right? I need t here, okay? The value of the t lah, to get the answer for dy dt and also the dx dt. How to get the value of the t? So again, by using the passing point, because we know that our x coordinate is the e. So I will show you here, when x is equals to e power 1. Okay, so substitute into your x equation. So from here, tangent t is equals to 1. You combine the power with the power. Press tangent inverse 1, you'll get pi over 4 for your value of the t. Then same thing happens for this part. When y is equals to 3, we're having 3 equals to 3 tangent square t. Your tangent t is equals to plus minus 1. Okay, then the t, if you try to press calculator, tangent inverse 1 will give you pi over 4. Tangent inverse negative 1 will give you negative pi over 4. Alright, yeah. Then let's continue further. If I know the value of the t here, okay, so this part got 1t, this part got 2 value of t. Which one should I accept? You have to accept the t that only appear in both of the parametric equation. So our overlapping t is this one, at t equals to pi over 4. Okay, substitute this value into my dy dx, dx dt. Alright, so I'll be having secant square pi over 4, t is pi over 4. Then e tangent pi over 4. What's the value for secant? The secant basically is 1 over cos square, right? So 1 over cos square, cos pi over 4, I will be having sec 2 over 2. Then you square it. Then e, tangent pi over 4 is a 1. Okay, simplify this particular term. Maybe you can use calculator lah, or whatsoever. So it will become 4 divided by 2, which is a 2. So you're having 2e power 1 for your dx dt. So we apply the same thing for the y part. Okay, now so what is my dy dt here? Okay, substitute t into the dy dt. I'm having tangent pi over 4. Then multiply with secant square pi over 4. Okay, so what do I have here? Again, I'm having 6 multiply with a 1. Then secant square pi over 4 again is 1 over cos square. So I'm having 1 over square root 2 over 2, then square. So this part you'll get a 2, multiply with 6, you'll get 12. Alright, then after you get the value of dx dt and also the dy dt, then next step you can try to combine them and find out the gradient of the tangent, which is dy dx. So like what I show you in this part, yeah. So this is the formula for chain rule to get the dy dx. So dy dt multiply with dt over dx. So what will we have is dy dt is a 12. dt over dx will be 1 over 2e power 1. And you will get 6 over e power 1 as your dy dx. And please take note that this is basically the gradient of tangent. So we successfully get the gradient of tangent here, and also with this passing point. Okay, let us form the equation of tangent. Formula for equation of tangent is y minus y coordinate. So the y coordinate just now for the passing point is a 3, equals to n x minus x coordinate, so minus e power 1. Okay, so you'll be having 6 over ex, then minus 6, and simplify it, you'll be having 6 over ex, then minus 3. Okay, so you should keep your answer in the exact form. 6 over e is the exact form. Okay, don't change it become the decimal number, yeah, because they ask us that they are telling us that the m and c are exact value. All right, so this is what it calls exact value, right? Okay, right. Yeah, so this is how we solve question number 4. Okay, question number 5. We are given a polynomial. Then b, q, a are constants. So there are a few constants here, yeah, b, q, and a. Where's the q? Seriously? Well, yeah, the q is at the back. Okay. Then when fx is divided by this linear divisor, the remainder is negative 22 a power 3. When it's divided by this one, then the remainder is negative a power 3. Find the values of p and also the q. Alright. So I think for this one, right, I will maybe emphasize on the word remainder. When you have a polynomial with a divisor and they give the remainder, you can basically apply the remainder theorem, right? So I just write it here. The main idea that I have here is the remainder theorem, the polynomial part. Okay, so what does it mean by remainder theorem? Basically, it's like this. When you already have the divisor, right, it is a linear divisor. If you let x equals to negative 2a, you try to assume that x plus 2a is equals to 0, then you have x equals to negative 2a. When you directly substitute x equals to negative 2a inside the function of your polynomial, okay, then you'll get the answer which is equals to the remainder. So this is what we call as a remainder theorem, and we are going to apply it here, right? Okay, so the first one, I'm using the first information here lah. Divided by x plus 2a, remainder is negative 22 over 22a power 3. And I let x equals to negative 2a, apply the remainder theorem, then I will get the, so I substitute it into the function f, I will get the remainder equals to negative 22a power 3. Okay, substitute your x in your function here, or your polynomial here, so you're having negative 2a power 3 plus pa, then x squared means negative 2a power 2, then the x here is negative 2a, okay, then plus qa power 3 equals to the remainder negative 22a power 3. Yeah, then you need to simplify this one very carefully. So 8 times 3 is 24, a power 3. Then this one you'll be having 2 square is a 4, 4pa power 3, 14 a power 3 QA power 3 equals to negative 22A power 3. Okay, then I try to just group cancel off all the A power 3 lah. Okay, if you try to cancel off all the A power 3, then you'll form one equation for Q and P. Right, so let us start, yeah. For P, negative 24 minus 40 is negative 38. So I'm having 4P plus Q equals to negative 22 plus 38. Negative 22 plus 38, I will be having 16, right? Okay, then I'm having the first equation, Q equals to 16 minus 4P. Right, then how can I get the second equation? The second equation, I will get it by using this one. They give us another information. When fx is divided by 3x minus a, and the remainder is negative a cubed. And what should I let the x here? So x is equals to a over 3 lah. You assume that 3x minus a equals to 0, so you get x equals to a over 3. So I'm using the same concept here. When you let x equals to a over 3, and if you substitute it into your function, the answer that you get will be the remainder, which is negative a power 3. Right? Yeah, so the simply happen, we try to substitute in this value of x into the whole equation here. Okay, and it's also negative a power 3. Right, so let's try to simplify all this and see what we get here. Okay, I will be having 1 over 9 a cubed. Then this one will be p over 9 a cubed. Then 7 over 3 a cubed also. And also q a cubed equals to negative 1 a cubed. Okay, simply cancel off all the a cube here for every single term. Then by right, you'll be having p over q. Oh, sorry, this is p over 9, not over q, sorry. P over 9 plus q. Then move all the constant to the left. Negative 1 minus 1 over 9 minus negative 7 over 3. Then by right, I'll be having negative 31 over 9. Okay, then I get the second equation. Yeah, I think so. From here, you shouldn't have any problem to solve it, right? Because you already get two equations here, 1 and 2. Therefore, you can solve them simultaneously and get the answer. Okay, so first I try to multiply the whole equation with the 9 so that I get rid of the denominator 9. Then only I simplify them. Okay, I get the value for p equals to 5. Okay, then after that, of course, I will need to get the value for the q. I use the first equation, 16 minus 4p. Q will be equals to negative 4. Right, so this is how we get the value of p and also the q by using the remainder theorem to form the equation and also solve them simultaneously. Right, so this is how we solve question number. Okay, now we are at question number 6. We are given the complex number z1, z2, and also the w, okay, in the exponential form. They want us to state the value of wz1 and also the wz2. Give your answer in also the exponential form. Then the r is greater than 0 and also theta is from negative pi to positive pi. Okay, so what we have here is we want to get the value for the complex number lah. Okay, so to get a complex number here, since they give us the exponential form, so to get the answer in exponential form also you just multiply them. So wz1, w is this one. Okay, then what is the Z1? So Z1 will be 3e power pi over 4i. Okay, then I simplify the number, the constant, 2 times 3 is a 6. Then when you're having e power a and also e power b, you add the power together. So basically you're having pi over 2 plus pi over 4 with the I. Okay, then simplify the pi over 2 and pi over 4. By right, you'll be having 3 pi over 4. So this is my WZ1. Okay, then after that, how about the WZ2? So for WZ2, also the same, you just multiply the exponential form together. So I will be having 2e pi over 2 I multiply with 3 over 2 e pi over 6i. Same thing happen here, you multiply the constant together with the constant. So 3 over 2 times 2, you'll get a 3. Then e, and basically what we have here is we are having pi over 2 plus pi over 6i. Then from here, what do we get? You will be getting 3e power 2 pi over 3i. Okay? Alright, and this is what we have. Then for part B, on the sketch of diagram, they want us to show the point ABCD representing these 4 complex numbers here. Okay? Right, so before we draw it, maybe we need to roughly know a bit what is the meaning of the exponential form here. You get the exponential form here, right? Okay, so first of all, you need to know when I'm having a complex number in exponential form, it will be in this pattern, re power theta I. The meaning of the r here basically means the length of the complex number or the magnitude. Okay, and what about the theta here? So the theta here basically means the argument. Okay, and this argument we measure it from the positive x-axis, right? Okay, so length and also the argument. So when we want to draw any complex number on Argand diagram, we are having the imaginary part and real part, right? Real and also imaginary. Okay, let's start with Z1 first. So for Z1, you are having this 3e power pi over 4i. That means you are having the length is a 3, then the angle is pi over 4. So on the axis, right, you try to measure pi over 4 means 45 degrees. So that means it will pass through maybe 1 and 1. Let's say this is 1 and 1. Then when you try to draw it, it will pass through the point 1, 1, 2, 2 or 3, 3. Okay? Alright, then after that, you know that your line will pass through this point to have the angle pi over 4. Because if you try to measure the pi over 4 from here, okay, you pass through this point. So you can try to draw a line joining the origin with the point. But you have to make sure that you try to use the ruler and measure it, and you get the 3 unit length. Okay, because the length is 3 unit. Alright. Okay, so let me try to draw it nicer, yeah. So maybe I just sketch it up, but by right you should know that the angle is, okay, so this one is actually pi over 4. And then when you draw the length here, the length is 3 unit. That's the meaning for Z1. It is point A and Z1. Okay? Yeah, so that's the meaning. 45, pi over 4 is 45 degrees. So you try to measure it up and then draw the length 3 unit. Then after that, for Z2. For Z2, what do I have here? 3 over 2, which is the length with 1.5. And the angle is pi over 6. Pi over 6 means 30 degrees. So you try to measure also the 30 degree from the positive x-axis. It should be less than the pi over 4, right? And then the length is only half of this length. So you try to measure also half of the length, which is 1.5. Oh, I think this one is too long already. Okay, 1.5. Oh no. Okay, so maybe like this. Okay, this length is 1.5. You use the ruler and try to draw it out. And then you need to know that this angle basically is pi over 6. So that's the meaning also, right? Okay, this is basically the Z2 and they want us to label it as point B. Alright, so all the exponential form here, they will actually help us to know where should I draw our diagram. Okay, then next one. WZ1 becomes 6e power 3 pi over 4. 3 pi over 4 means 135 degrees. So we want to measure it, it will be 135 degrees. So measure 135 degrees from here. Then you need to have the length of 6 units. So it's this one. The graph that I draw might not be very nice, yeah. So please make sure that you draw a nice one. So 6 units I think is quite long, right? Okay, so this is the point C where it is WZ1. Okay, then after that for point D is WZ2. So the length is 3 and then 2 pi over 3. 2 pi over 3 is 120 degrees. This is 135, right? So 120 degrees should be somewhere here and the length is 3 units. So it should be somewhere here. Because you measure 120 degree, 120 degree from this part, from positive x-axis, alright? And then I should label it as D, which is WZ2. Okay, so when you look at this one, I just try to draw it. I didn't measure, right? But if you want it to be more accurate, basically when you try to draw the length of the line, you can use a ruler and measure it, the length. So this is 1.5, 3. Then this one is 3. Then this one is 6. Okay, so this is how we sketch the diagram. Right. Now let's continue further. They want us to state the geometric effects of multiplying Z1 and Z2 by W. Okay, so let's have a look. This is your Z1. After multiply by W, right, your complex number becomes this one. So we try to compare. Okay, so we try to compare the difference between Z1 and Z. So let's have a look for this one. Original Z1 is a 3, right, with the magnitude. After you multiply with the W, it will become 6. So you can see that the difference here is times 2. The length become 2 times longer. Same thing happened for the Z2. Original length is basically 3 over 2. And then after you multiply with the W, it will become a 3. So you compare it here also, you will realize that it is actually 2 times longer. Okay? Then after that, if you have a look for the angle, so from Z1, the argument is basically pi over 4. But what happens if, let's say, you multiply the W with the Z1? So the argument of W multiply the Z1, right? You'll get the argument 3 pi over 4. That means you can see that you add 2 pi. What is the meaning of adding 2 pi here? Adding 2 pi here means that you are going to rotate your original Z1 pi over 2 degree in anti-clockwise direction. You can see here, this is actually pi over 2. If you try to measure, it will be a 90 degree. Alright? Then same thing happen for the Z1, Z2. If let's say you're having the argument Z2, if you realize it, it is actually pi over 3. Okay? Oh, sorry, pi over 6. Then when you multiply with ZW, with Z2, then your argument become 2 pi over 3. That means you're adding pi over 2, right? So adding pi over 2, what does it mean? It means that you are rotating the Z2 in pi over 2 unit anti-clockwise to get WZ2. So there's a small relationship between the length and also the argument in the complex number here when you multiply two complex numbers together, right? Okay, so what they want us to do here is they want us to state the geometric effect. So there are two. Just now you realize that the length become double, right? So you can just tell them that there's a stretch in length of Z1 and Z2, okay, with the stretch factor 2. Maybe you can just tell them that it is a stretch factor in length, then with a stretch factor 2. Okay, then the other one is the rotation, right? The angle, the argument. So we will say that it is a rotation in pi over 2 radian anti-clockwise. Yeah, so this is how we solve question number. Question number 7. They want us to express this one in this form. Okay, r is greater than 0, alpha is in the first quadrant. State the exact value of r, then a is 3 decimal places. Okay, so for this one, before we can change it become the r sine x minus alpha form, we have to try and expand this compound angle triangle first, right? When you are having sine a plus b, so or maybe sine a plus b lah. Alright, so what's the general formula that you can expand, use and expand? So it should be sine a cos b, then plus cos a sine b. Okay, then what else do I have here is what should I do here? Yeah, I think you just need to apply this formula, then after that rephrase it, you'll get the answer, right? Okay, then maybe let's start. Okay, so first of all, I'm having this equation. Okay, expand sine x plus pi over 6 by using this formula. I'll be having sine a cos b, sine a cos b, then plus cos a sine b, minus 4 cos x. Okay, so next one, I will be having 5 sine x. Value for cos pi over 6. Cos the pi over 6 means 30 degrees. So you'll be having cos pi over 6 is 3 over 2. Because you have to keep your r in the third form, right? So in the exact form, therefore all the answer here, please keep it in the third form. And this one, we're having 5 cos x multiplied with sine 30 degrees, which is a half. Okay, then minus 4 cos x. Then group the sine together and all the cos together. I will be having 5 sub 3 over 2 sine x. Then plus all the cos x together, I'll be having 5 over 2 minus 4. What's the value for 5 over 2 minus 4 here? Okay, so by right, you'll be having negative 3 over 2. Alright, after I change it become this pattern, then only I can make it become r sine x minus alpha form. Right? Then what is the general formula again? If you are having a sine x plus b cos x, then you can change it become r sine x plus alpha, where you need to know that the r basically comes from the formula of square root a square plus b square. And to get the alpha, it is tangent inverse b over a. Okay, so we are going to use this one. Right, so to find the r, what's the value of the r again? So square root a square plus b square. So the sign here will be sine 5 sub 3 over 2. So 5 sub 3 over 2 square plus b square. So the b square is negative 3 over 2 with a square. Okay, then when you try to simplify it, by right, you'll be having square root 21. Alright, then how about the alpha? So like what I told you, alpha is tangent inverse b over a. Without using the negative, yeah, so 5 sub 3 over 2. Okay, then if you want to make your answer into 3 significant figure, the answer that you get should be 0.333. Right, so successfully get the value of the r and also the alpha, then let us compare. Okay, so for our equation here, right, this is a minus, right? So therefore, they ask us to change it become minus. Basically, you should write in this side, it is plus minus here, this is the plus minus inside. Okay, right. After you get the value for r and also the alpha, then you can directly write out your answer again. Your answer should be 5 sine x plus pi over 6 minus 4 cos x. Eventually, it can be written as r, which is square root 21, then sine x minus 0.333. Your alpha correct to 3 decimal place. So I think in this question, they requested for 3 decimal places, yeah? So this is the answer for the alpha. R must be square root 21 because R must be exact. Okay, this is what we have for part A. Then let's continue to part B. Alright, so for part B, they want us to solve this equation and you let it equal to square root 7. If you have a look for the expression just now, right, we are having this 5 sine x plus pi over 6 minus 4 cos x. That means we are changing it in x into 2 theta. When I want to solve this equation also, I use my result in the first part, where originally I'm having square root 21, then sine x minus 0.333, right? But in this question, they have changed the x become 2 theta. Therefore, I have to also substitute it by using the 2 theta. It is equals to square root 7. Then we continue to solve it from here. So sine 2 theta minus 0.333 is equals to 1 over 3 square root. Alright, then before we can get the answer for the theta, we need to get the basic angle first. So the basic angle will be sine inverse square root 1 over 3. What's the basic angle that we get? I get a long value, right? So I try to keep it longer so that I simplify the answer in the very last step. Alright, yeah. So I keep my answer longer. Then now I need to go through the quadrant and see which is the angle that I want to accept my answer. For this question, they are asking the theta is from 0 until pi. But in my equation here, I'm having 2 theta. That means if I want to go through the quadrant, I have to go through the quadrant from 0 until 2 pi. That means one cycle. Alright? And how can I get an answer from the different 4 quadrants here? Basically, it's like this. First quadrant, everything is positive. Second quadrant, sine is positive. Third quadrant, tangent. Then fourth quadrant is a cos. To get the answer here, first quadrant answer is basic angle. And I put it as theta, basic angle. Second quadrant is pi minus basic angle. Third quadrant, pi plus basic angle. Fourth quadrant is 2 pi minus the basic angle. Then let's start. This value, square root 1 over 3 is, square root 1 over 3 is basically a positive value. And we are looking for sine with a positive value. So you ask yourself, in the first quadrant, okay, so in the first quadrant, is it sine positive? Yes, right? So to get the answer from this quadrant, we are using the basic angle. So I just substitute by using basic angle, 0.615480. And then after that, for the second quadrant, is it sine positive? It is also positive, right? So to get the answer from this part, you take pi minus the basic angle again. So you'll be having a long number also, 2.526 something. Alright, so usually I keep it longer because this is not my final answer yet. Then I will only simplify until the very last step. Alright, okay. After that, to get the third quadrant answer, okay, you look at this. I'm looking for sine positive, but in the third quadrant, sine is negative, so I don't take the answer from this part. In the fourth quadrant, cos is positive only, but I am looking for sine positive. Therefore, I also don't want the answer from this quadrant as well. Okay, after I go through one round, then I can stop because they did mention that 2 theta is from 0 to 2 pi, right? So I can just stop after I go through one round. And these are the 2 possible answers that I will have. Okay, so to get the value of theta, you just need to make sure that you move the 0.333 over. And also after that, you divide it by 2. Okay, so when you plus 0.333 and divide it by 2, your final answer should be 0.47 and also 1.43. So why do I keep my answer in this form? Is because of my final answer is 2 decimal places requested by the question. Right. So when you press the calculator, please try to press it longer and then only simplify your answer in the very, very last step into the accuracy that the question wants. So this is how we solve question.
Right, so question number 8. With respect to the origin O, the point A and B have position vector. So we are having the position vector for A and B here in vector form. Then the line L pass through the point A and B, form the vector equation of the line L, right? Okay, so our general formula for the vector equation is R equals to A plus TP, where A should be the passing point. So we are having two passing points here. The first passing point is the A, the second passing point is the B. So we have more than enough to set up this one. For the passing point, we have two options here. And after that, we are having the T and P. P means the direction of the line. If we have the line pass through the point A and B here, basically the direction of the line can be A to B or B to A. Alright, so the P here will be the direction AB lah. Okay, so once we know about it, then we start forming the equation. So first of all, I know that my direction of the line is equals to AB. Of course, if you want to use BA also can, no problem. So AB means AO plus OB. What do I have for AO? So AO will be 2, 0, negative 2, right? Because OA is 2, 0, 4. So AO will be negative 2, 0, negative 4. Then the OB will be 5, 1, 6. Alright, so simplify them. You'll be having 3, 1, and also 2. And this will be my direction of the line. And now we can write out straight away in the vector equation form. So like what I told you just now, it will be R equals to A plus TP, right? So you can use the passing point, either the A or the B, both also can. So for me, I'm using the A because there's a 0 inside. I prefer to have something more simple one, right? So we are having 2, 0, 4. This is the passing point, plus T, then P. P is the direction we found just now, which is 3, 1, 2. And this is your vector equation. Okay, so this is the column vector form. If you don't want to put it in the column vector form, of course you can put it into the IJK form, where R will be equals to 2I plus 4K plus T with 3I plus 2J, plus 1J plus 2K. Alright, so no matter what form also can, as long as you make sure that it is a vector equation of the line L. Okay, so let's continue to part B. Now for part B, they said we are having another vector equation, line L1, line L2. Just now is L1, so now is L2. Now they want you to show that L1 and L2 do not intersect. Okay, so if we want to prove that they do not intersect, so we have to solve them like we want to find the intersection point first. So usually when you're having two equations, how you find the intersection point? You let equation L1 equals to equation L2, right? Then you try to solve them simultaneously. Same thing happened for here. I let equation L1. So the vector equation L1 that we get just now is 2 plus 3t, then 0 plus 1t, and also 4 plus 2t. This is equation of line L equals to equation of line number 2. So what's the equation for line number 2? It is provided here. If you try to group that, it will be 2 plus mu, then 1 plus 2 mu, and 5 plus 3 mu. Okay, so I hope that you know how I actually combine them become this one. Right. Then from here, you basically can see that there are three equations here. First equation, second equation, and third equation. Alright, so we have to get the value for t and u first, t and mu. To get the value for t and mu, you no need so many equations, right? You only need two of them. So please try to use any two of them, right? For me, I'm using 1 and 2. I'm using 1 and 2, yeah? So if you want to use other one also can, like some students, they might want to prefer to use 1 and 3 to solve. Or maybe some of the students, they prefer to use 2 and 3 to solve. Both also can, right? So for me personally, I'm using 1 and 2. I will sub equation number 2 into equation number 1. And from here, what do I get? So I'll be getting 2 plus 3, then t. T I will substitute by using 1 plus 2 mu equals to 2 plus mu. Okay, then I will be having 2 plus 3 plus 6 mu. Then 5 mu equals to 3, negative 3. And after that, mu equals to negative 3 over 5. Okay, and I want to get the value of t as well at the same time. So I substitute it back into the first equation. So t equals to 1 plus 2 mu, right? So I'm having 1 plus 2, then mu. Mu is negative 3 over 5. Then from here, I get my value of t, which is negative 1 over 5. Alright, so here I need to emphasize something here. Because for this question, we already know that they do not intersect, yeah? So just now, if we are not using 1 and 2 to solve the equation, to get the value for t and mu, let's say you use 1 and 3 to solve the equation, then the value of mu and also the t that you get might not be the same. It will not be the same as my one. Understand what I said? Because for me, I'm using 2 and 1, 1 and 2. So if you use 1 and 2, then definitely you'll get this answer. But if you're using other pair of equation to solve, right, to solve it simultaneously, then the value of mu and also the t definitely will not be the same in the case which is do not intersect. All right, so you please take note on this, yeah. Right, so after you get your value of mu and also the value for the t, what should you do? How can I prove that they do not intersect? So we have to prove it in this way. After you get the value for mu and also the t, right, please substitute it back into the equation that you haven't used just now. So for my example here, I'm using 2 and 1 to solve for the answer, right? So later, I will need to use the equation number 3 to prove that they are not intersect. Right, so how to prove? So let us have a look. We have to substitute the value of mu and also the t, go back into the third equation. So I substitute the right-hand side, left-hand side of the third equation. So what do I have here? I'm having 4 plus 2t. So I substitute the value of t into my equation. So it will be having negative 1 over 5 here. Then simplify it, get the value. So the value that I get should be 18 over 5. Same thing happened for the right-hand side. I want to substitute the right-hand side by using the value of the mu. So 5 plus 3. Mu, I get negative 3 over 5. And when I try to simplify them, I get 16 over 5. Yeah, from here, we can see that left-hand side value is not equal to the right-hand side value. That means all the line 1 and line 2, they are skewed case. Line 1 and line 2 do not intersect. So do not intersect means that intersect. Means that they are skewed case. They are skewed. Alright. And how about if let's say the question, if the line 1 and line 2, they intersect with each other. If they intersect with each other, then basically left-hand side equation will be equal to the right-hand side of the equation. So this is how we separate, we differentiate the skewed case and also the intersection case. So intersection case, all the equation will be having the same value of mu and t. But if they are the skewed case, then when you substitute the value of u and t that you get, you might not get the same value for left and also the right hand side. So this is basically how we prove them. Okay? Yeah. Then let's continue further. We still have part C here, right? Okay, part C. Where's the part C? Okay, so part C is here. Find the acute angle between the direction of line 1 and line 2. To find the acute angle between the line, you have to use only the direction. Okay, and the formula of finding out the acute angle, the angle for between the vectors, remember, we're having P dot Q equal to modulus P, modulus Q, then cos theta. Alright, and now, what's the P and Q here? P will be the direction of line 1, Q will be the direction of line 2. Let's take out the line 1 and line 2 first. What's the direction for line 1 just now? We are having 3, 1, 2, right? What's the direction for line number 2 just now? Okay, look at the value beside the mu. It will be actually 1, 2, and 3. Okay, then now we are trying to apply this in our formula here. So I'm taking P dot product with the Q. Then I want to have the modulus of P. So to get the modulus of P, it is 3 square plus 1 square plus 2 square. To get the modulus of Q also, it will be 1 square plus 2 square plus 3 square. Then cos theta. Okay, so next, let us simplify the equation. Dot product means you take x multiplied with x. 1 multiplied with 3, you get a 3. Plus 1 multiplied with 2, you get a 2. Plus 2 multiplied with 3, you get a 6. Then simplify all the value on the right hand side. So I'm having square root 14, square root 14, then cos theta. Continue further, I move all the number to the other side. I'll be having 11 over 14. Then to get the theta, I just take cos inverse 11 over 14. And let's see what is the answer that I get. So if you didn't do any careless mistake, your answer should be 38.2. Of course, you want to put it into the radian mode also can, the radian form also can, no problem. Alright, then I just keep it in the acute angle, in the angle form, in the degree form. It will be 38.2 degree. Yeah, right. So this is how we solve the question number 8. Alright, so question number 9. We are given the equation like this that involve the integration. So there's a constant a, right? So they want us to show that a is equals to exp, then this value here, where exp, x means the e power x. Alright, so how can we get this equation here? And basically, we need to solve this inequality first, this equation first, alright? So if we solve this equation, we try to rephrase it, so I believe that you will get this answer. Okay, and now let's have a look. What is the technique for us to apply in this integration? Okay, you can have a look where there's a multiple of two different functions here, a multiplication of two different functions here, and they belong to different pattern where I'm having this is actually the algebra, right? And then I'm having ln is logarithmic function. Okay, and when we are having the multiplication of two different functions, most of the time we are going to use the integration by part to solve the integration. Most of the time, of course, we also have the cases where both functions are the same group. Okay, like sine x, cos x, you also can use the integration by part. But most of the time, you can see that when you have multiplication of two functions, then you can try to think about the integration by part in our syllabus, right? But this is, of course, just a general guideline to make sure that you identify correctly. Of course, you still need to practice a lot. Alright, because there are some other cases like f prime x multiplied with fx1. So that kind of question might appear in other syllabus, but at least in our syllabus, I think so far we didn't see it a lot, right? Yeah, so from here, I usually ask myself, okay, I'm having the multiplication of two functions, then I always try to use the integration by part to solve the integration. What's the formula for the integration by part here? The general formula is, if I'm having the question integrate u dv, the formula will be uv minus v du. This is the integration by part equation that I'm using all the while. It is a bit different from the formula booklet, but the formula booklet is with the dx one. So I just cancel off the dx in the formula booklet, then this is what I get, right? So that's the formula that we have to use now. But of course, we need to decide which one in the question itself belongs to the u and which one in the question belongs to integration of dv. Alright, then basically we have one general rules to apply. You can use LIATE or ILATE also can. ILIATE Liat rule, or you can use ILATE, LIATE. Both are the same actually. Okay, so for L means logarithmic function, logarithm. I means inverse trigo, inverse trigo. A means algebra, including all the polynomial number and everything. T is the trigo, and E is exponential. Okay, when the term is belongs to the higher group, then it will be the u. If it is belong to the lower group, then it will be the integration of dv. So let's have a look for our question here. Okay, and what do we have? So we are having 6x. 6x will be the algebra. Ln x will be the log. So very obvious, the higher group will be the u. So u equals to ln x in our question here. Therefore, the integration of dv will be equals to integrate of 6x dx. Okay, so that's the first step, right? We have to decide which one is the u, which one is the integration of dv first. Then after that, for the u part here, we try to differentiate it. So I'm having du over dx equals to 1 over x when you differentiate ln x. Okay, Then what do I have for the du? So du is equals to 1 over x dx. Therefore, this part we are going to integrate it. Integrate 1 dv, I'm having the v. Integrate 6x squared, 6x, I'll be having 6x squared divided by 2. Then after I simplify it, what do I get? So 6x squared divided by 2. Power plus 1 divided by the new power, right? Then simplify, you'll be having 3x squared. That's the v. Okay? Yeah, then after I done with this part, then I can start my integration. Let me copy the question first. So the question is this one. This is our integrate uv. Integrate u dv. Integrate u dv, this one. Okay? Right, so I just try to copy it, yeah? So I'm having integration of 1 to a, then 6x ln x dx equals to 4. And I want to apply integration by part at here, right? So what I do is I substitute the formula here. uv, what is your u? U is ln x. Then v is 3x squared, and I prefer to put the 3x squared in front. So 3x squared multiplied with ln x. Then you have to substitute in the limit a and 1. Okay? Then after that, minus. So you copy the minus. Integrate, you put the integration sign. Then limit, also copy back 1 to a. v du, what is your v? V is 3x squared. What is your du? Du is 1 over x dx. And this part will be equals to 4. Okay, then for the first term here in front, you can substitute in the limit. So I'm having 3a squared ln a minus 3, let's substitute 1, 1 squared ln 1. Okay, then the term at the back, I'm having 3x dx, it is equals to 4. Right, then we try to simplify further. Ln 1, you should know that it is basically equals to 0. Therefore, the term in front, I left only 3a squared ln a. Then minus, I integrate this part here. Integrate 3x, you will be having 3x squared over 2. And you need to substitute in the limit of a and also 1. It is equals to 4. Okay, so we just need to further simplify it and rephrase the answer, then basically we'll get the value. So I'm substituting value a squared minus 1 squared equals to 4, then 3a squared ln a. Okay, then now let us copy what the question wants us to prove, yeah? So they want us to prove this one. It will be basically a equals to e power 1 over 6 with 5 over a squared plus 3. Okay, so this is what they want us to prove. Right, I copy it down so that I can refer it. Okay, this is my final answer. How can I get this answer from the equation that I'm having here? Okay, so first of all, maybe I try to keep the term with ln a on the left first, because I suspect that later when I want to get the ln over, it will become e power something. So I keep it on the left first. Then all the rest of the term to the right. Then when I put all the rest of the terms to the right, I'll be having 3 over 2 a squared. Then minus, minus 4 minus 1 over 2, 3 over 2. So you'll be having 5 over 2 positive. Okay, then next one, I bring 3a squared over. So 3a squared over will make it to become something like this, yeah. What do I have here? 3 over 2a squared, right? Okay, so when I bring it downwards, I will be having 1 over 6. Is it 1 over 6? No, 1 over 2 only. Okay, 3a squared and the 3a squared will be cancelled off. Alright. Yeah, then after that, bring the 3a squared over, I will be having 5 over 6a squared. Okay, and then after that, if I try to compare my answer with the final answer provided by the question, you can see that they actually have 1 over 6 outside the term. So maybe before I do anything, I try to factorize out the 1 over 6. Because I realize that if I factorize out the 1 over 6, I'll have exactly the same term here, 5 over a squared. Then take out 1 over 6 from half, you'll be having a 3. So I think it's correct already. Then I bring the ln over, it becomes e. E power 1 over 6, then 5 over a squared plus 3. Right, yeah. And this is how we prove the equation that we want to solve, to show. Okay, then let's continue further and see what they want us to prove now. Okay, part number B. They want us to verify by calculation that A lies between 2 to 2 and 2 to 1, 2.1. Okay, so to verify this one, basically it involved the sign change method. For me, I'm using sign change, yeah. So some of you might not using sign change. Okay, so to use sign change method, basically I need to use the equation that they want me to prove just now. This is the equation that I proved just now, right? Okay, I want to make it into the function. So when I want to make it into the function, I would have make it into FA. Then either you move the A over to the left, or maybe you move this term to the right. Okay, so for me, I'm moving the E, become negative E, 1 over 6, 5 over A squared, then plus 3. Right, then after that, I substitute the value 2 into the function, and I'm having 2 minus E 1 over 6, then 5 over 2 square plus 3. Then I get the value. So the value is a negative value, 0 0.0306 if I don't do careless mistake. Right. Then after that, I need to substitute the value 2.1. And what do I get here? So 5 over 2.1 square plus 3. And the value that we get should be 0 0.108. So from here, basically you can see that there's a sign change here from negative to positive. So just now, if you try to move A to the left hand side, A to the right hand side, then your sign will be opposite. That means you are having positive for 0 0.0306, then negative for 0 0.108. Okay. Then don't forget to make any some simple conclusion. So I will usually say that the sign change can be seen between F2 and F2.1. Okay, therefore we can say that the A actually the A lies between these two values. Okay, but of course the main idea is you have to prove and show that there's a sign change occur between these two values. Alright. Okay, then let's continue to part C. For part C, use an iterative formula based on the equation in part A to determine A correct to 2 decimal places. So our final answer should be 2 decimal places. Each iteration is 4 decimal places. Right. Okay, so what's the iteration formula again? So we are using back the original iteration formula. A equals to E power 1 over 6, 5 over A squared plus 3. Yeah, so basically we are using this, the right hand side one, this iterative formula here. Okay, alright, so to find out the answer by using the iterative formula, you can use a calculator to help you. Therefore, we have to key in the iterative formula into our calculator. I'm having E, so E power got fraction, right? And I have 1 over 6. Then put a bracket, you multiply. What should I do? Maybe I put a multiply better, right? Multiply with the bracket of 5 over A squared. And now we don't use the A, we use X. Okay, so X squared, then plus 3. You have to make sure that you input the equation correctly, because if the equation is wrong, basically all your answer might not be the correct one, right? So this is a very important step, yeah? So always double check your equation before you continue for the calculation. Right, For this question, they didn't tell me any initial value. Therefore, I will use the value that I want. And I realized that the 0, the 2, when you substitute the 2, the value of 0 is closer. It is closer than that. It is closer to 0 compared with 0.10a, right? So to me, I will start from 2 lah. If you want to choose any other value, you can just make this value 2 and 2.1 as a reference point. You can start with any value that's close to these two. And of course, if you want to try the larger value also can, but maybe your iterative will be slightly longer. I'm not sure, but basically that's the idea. Usually you don't choose a value that's too far away from what they asked just now. Okay, right, then continue further from here. For me, I'm getting the first initial value is a 2. Then to get the value for a2, basically you have to substitute the 2 inside the equation. So 1 over 5 over a square. The a square here will become the 2 square. So 2 square plus 3. Alright, then how to get the value from calculator? You can press calculate. Then you key in the value of 2. Then you press equal sign. You are getting this value 2.030604097. It's very long, right? And this is our iterative, and we should cut it short into 4 decimal places, and it should be 2.0306. So here I will write out 2.0306. Okay, then for the next value, a3, how to get the value for a3? Substitute 2.0306 into your iterative formula again. In our calculator, you just press calculate one more time, then key in the value 2.0306. Then press equal sign. Then we'll be having 2.0180. 4 decimal places, right? So I'll get 2.0180. Okay, then continue further. Repeat the process again, calculate. Key in the value 2.0180, 2.0180. Press equal sign. And I get this value 0.0231. 0.0231. And when should we stop? Usually for me, right, before I can stop the iteration, I will double check the answer for 2 decimal places first. Okay, so like for A3, answer for 2 decimal places is 2.02. The answer for the fourth iteration is also 2.02. So you have 2 decimal places answer repeated here, right? If you want, you can actually stop here already. But for me, usually I want it to be safe. I will just try extra one more iteration. Okay, then I press calculate again, key in the value 0.0231. Then press equal sign, and you get 2.0210. 2.0210. So if you double check the answer with 2 decimal places, it is still 2.02. So from here, when I get 3 times of repeated value in 2 decimal places, then I will write it out as root is equals to 2.02, correct to 2 decimal places. So this is how you check and verify that you can stop. Okay, so you cannot stop until you get the repeated value, right? Then if you are using some value that's very far away from the 2 and also 2.1, then your iteration might be slightly longer, okay? Yeah, so this is how we solve question number 9. So let's continue with question number 10. Right, we are given the polynomial, and then we want to find out the quotient and also remainder when the polynomial is divided by x squared minus 3. Okay, there are many ways for you to do it. You can write out the equation and compare them. Then for me personally, I will use the long division to complete this one to get the quotient and also the remainder. Alright, so let's start with the long division. I will put the polynomial inside. And after that, I will write the divisor outside. And for this divisor, right, because there's no term in x, but usually for me, my habit is I prefer to put it as 0x. If let's say there's no term in x, I'll put it as 0x. So that later when I do the long division, it will not be too confused for myself, right? Okay, then let's have a look here. You have to decide a value or something multiply with x squared to get the x power 3. We always focus on the first term. Something multiply with x squared to get x power 3. So the something here should be the x. x multiplied with x squared, you're having x power 3. X multiplied with 0x. So just now you multiply the first term, right? Then you have to multiply the second term also. So x multiplied with 0x, you're having 0x squared. And the third term is x multiplied with negative 3, you'll be having negative 3x. Okay, and after that, continue. You have to take the term on top divided by the term minus the term at the bottom. So 3x power 3 minus x power 3 becomes 0. 5x squared minus 0x squared, you'll be having 5x squared. Negative 2x minus negative 3x, will be having x. Then bring the 15 downwards. Okay, then we have to decide the second term now. Something multiply with x squared to get 5x squared. So the something should be 5. And now you're having 5 multiply with x squared, then you have 5x squared. 5 multiply with 0x, we'll be having 0x. Then 5 multiply with negative 3, you'll be having negative 15. And if you try to simplify it, you take the term on top minus the term at the bottom. So 5 squared minus 5 squared becomes 0. So x minus 0x, that means 1x minus 0x, we're having the x. 15 minus negative 15 becomes 0 as well. So we have ended our long division here. It is because of we are having the degree of the divisor is a 2 and the remainder here is a 1. So you cannot continue the long division anymore. Right? And now, where is the quotient? Basically, you have to know that this is the quotient. And this is the remainder. Right? And to show the answer clearer, I will always write out clearer. So I will try to list out my quotient in the question. So quotient will be x plus 5. And the remainder will be x. Okay, so this is what we have. And if in the question, if let's say they want us to write out the equation correctly that involve polynomial division and also the quotient, basically we should know that it can be written like this. So we are having px. Let's say this is px, yeah. Then this is the divisor. Alright, so we should know that px basically is equals to quotient multiply with the divisor and plus remainder. Right, so I believe that some students might using the comparison method to solve this one, to get the quotient and remainder. If you want, also can. Alright, but basically this equation is the general equation, how we get the polynomial from quotient, divisor, and also the remainder. Alright, yeah, we are going to use this also in the next part. So let's continue further. Let's look for part number 2. Now they say that the variable x and y satisfy this differential equation. So I'm having a differential equation here. They also give us an initial value or maybe a related value, the value that fulfill the equation. Solve the differential equation to obtain an expression for y squared in terms of x. Okay, then let's continue. To solve the differential equation, in our syllabus, we're having the separable variable differential equation. That means that you can separate all the variable x to one side, all the variable y to the other side, and you try to integrate both sides. Right? And to solve this, to do this, of course, we have to start from the question here. So I'm having dy dx equals to x power 3 plus 5x squared minus 2x minus 15 divided by 6y, then x squared minus 3. I only have x and y, right? Then I think I want to keep the y. I want to bring the y to the right. Then maybe along together with the 6 also. Right, I'm having 6y, then dy. Then the remaining term, I keep it on the right here. Oh, so just now I want to move the 6y to the left, not the right. Okay, then x squared minus 3 with dx. So I want to bring the dx from left hand side to the right. Okay, then you can see now clearly that I have successfully separated my variable, all the y at one side, all the x at one side. Then I will put integration sign on both sides. I will start my integration. Okay, then to integrate this term, basically it's not a big problem because it's a simple integration. Maybe for this one, it will be a bit more complicated, okay, because it looks like a complicated fraction where you're having a long polynomial on top and also the x squared minus 3 at the bottom. But if you try to have a look for this meaning, basically it means that it is x squared plus 5x squared minus 2x minus 15 divided by x squared, x squared minus 3. Okay, and this is basically what we did just now in part A. I don't know whether are you aware or not. Alright, so we are actually having this polynomial divided by x squared minus 3. And in part number B, you can see also that we are having the polynomial divided by the x squared minus 3. And basically, we have to use the result in the first part to apply it here. Alright, and like what I told you just now, we are having this general equation, right? The polynomial is equals to quotient multiply with divisor plus remainder. And now, if I bring the divisor over here, or I divide every single term here by divisor, then I'll be having px over dx equals to qx plus rx over dx. Why I want to divide every single term here by using dx, it is because of, in my question here, I have the expression on top is actually the px. The expression at the bottom is actually the dx divisor, right? When I'm having px divided by dx, this is what we have, px divided by dx. I can further rewrite it become quotient plus remainder over divisor. That means what I want to do here is, for the next step, I want to change my fraction become this one. So quotient is what? Quotient is x plus 5, right, from part A. Plus remainder, what's the remainder? Remainder is the x divided by the divisor, x squared minus 3. Okay, so this is my purpose. I want to have my equation px over dx so that I can replace it by using this one. Okay, so I'm having quotient x plus 5. Remainder is the x divided by the divisor x squared minus 3. Okay, then now let's have a look. How can we continue with the integration? Again, this one now become still a simple integration. Now the x plus 5 is a simple integration as well, right? Because they are all the single term and then it can be integrated very easily. Then for this one, maybe you have to figure out a little bit, right? What is the pattern it belongs to and what is the formula that we can use. Okay, so let's integrate the simple terms first. Integrate 6y. 6 is a constant, you just copy. Integrate the y. Y is power 1. Power plus 1 become a 2 divided by the new power 2. Then equals to x. Integrate x will be having x squared divided by 2 divided by the new power. Integrate the 5, you will be having 5x. Then now, I want to integrate this one. X over x squared minus 3. When we are having a fraction, and then you try to have a look for the relationship between the x squared and also the x, you need to know basically that my x squared minus 3, right? I can let it become fx. If let's say my fx is x squared minus 3, what will happen if I have f prime x? So f prime x will be 2x. And on top here, basically I'm having the x. So this pattern belongs to the f prime x over fx pattern. Okay? And when you see this relationship, you can actually try to relate it with this one. If I have f prime x on top, then divided by fx at the bottom, and you want to integrate it, basically you'll be having ln, then fx plus c. Okay, then of course this pattern you have to try to figure it out by yourself, yeah. And then when you try more questions, of course you'll gain some experience from there. When you look at it, oh, okay, I know that the x is actually the differentiation of x squared at the bottom. So you can suspect that you are having the f prime x over fx pattern. Alright. Yeah, so that's why trying a lot of questions is very important, because from there you can observe the suitable technique or method that you can use. Alright. But now our problem is I want to have 2x on top, but I only have the x on top. What can I do now is I have to adjust it become 2x. When I multiply the 2 in the equation or in the expression, I want to make it balanced, right? Therefore, outside I have to divide it by 2. So that when I have times 2 and divided by 2, the expression is still the same. Just that the pattern looks a bit different only. And now when I put the 2x on top, the 2 on top already, on top I'm having 2x, which is exactly the f prime x. Then the bottom is exactly the fx. Alright, and now we are having this correct pattern now, f prime x over fx pattern. Then we want to continue and integrate this part. Okay, so before that, I try to simplify it first. 6 divided by 2, you're having 3y squared. Then you're having x squared over 2, nothing special here, plus 5x. Then plus half. Half you should just try to copy. Integrate f prime x over fx, you'll be having ln x squared minus 3. Then don't forget about the plus c at the last term here, because your integration has completed. Right. Then now, before you try to rephrase your answer y squared in terms of x, try to get the value for c. How can I get the value for c? Of course, you have to use the initial value given in the question, x equals to 2 and also y equals to 2. So let's continue from here. Given x equals to 2, y also equals to 2, what will my equation look like now? So substitute the y and x into the equation here. So I'll be having 3, then 2 square, plus 2 square over 2. Oh, sorry, it should be equal, right? Okay, square equals to 2 square over 2 plus 5 times 2 plus half ln sorry, then 2 square minus 3 plus c. Okay, then I'm having 4 times 3 is a 12. I have a 2 plus 10 plus 12 ln 1 plus c. And if I try to simplify everything here, basically my c is equals to 0. Okay, and now let us come back to our general solution here. They want us to express y squared in terms of x, right? So I try to divide or bring the 3 over. So when you bring the 3 over to the right hand side, it becomes divided, right? I'm having 1 over 6 x squared plus 5 over 3 x, then plus 1 over 6 ln x squared minus 3. And of course, the plus c is equals to 0. So I think this will be our final answer here. This is what we get for the y squared in terms of x. Okay, then if you try to look again the solution here, basically you need to apply the result in first part when they ask you to do the long division to find the quotient and remainder. Then after that, you need to know also how to integrate the specific pattern of the integration. Alright, and this is how we solve question number 10. Alright, so question number 11, which is the last question of this paper. Right, the diagram shows the curve of this one, and they only draw the curve from 0 to pi over 2. Right, the curve has a maximum point, maximum, highlight the keyword, at m, where x goes to a. Find the exact value of a, highlight the keyword exact. Alright, so to find the maximum point, basically you should know we have to find the dy dx and we let it equals to 0. Okay, and after that, when you look at this equation here, basically it is the product of two functions, right? Therefore, when you want to apply the differentiation for the product of two functions, you have to apply the product rule. So how to get the product rule? It is something like u dv dx plus v du dx. This is the formula for the product rule. For me personally, I'm trying to memorize it by using the first and second bracket. This is the first bracket, second bracket. Copy the first bracket, differentiate the second. Then copy the second, differentiate the first to get the dy dx. Alright, it is actually the product rule. Just that I try to memorize the step only. Okay. Right. Then after that, after you get the differentiation, you let dy dx equals to 0. Then from there, you can get the x coordinate for the maximum point, which is the a. Alright. So let's start. I'm having y equals to cos x, then sin x, sin 2x power half. Okay, so to get the dy dx, now I copy the first bracket, differentiate the second. I'm having a bracket with power half, right? So for differentiation, you put the power in front, copy the bracket, power minus 1 become negative half. Then you have to differentiate the thing inside the bracket. Differentiate cos 2x, you're having, differentiate sine 2x, we're having cos 2x. Then differentiate the 2x, we'll be having the 2. Then this is copy the first bracket, differentiate the second. Now I want to differentiate the first bracket, copy the second. Differentiate the first bracket is cos. Differentiate cos, you have negative sine. Then I copy the second bracket, sine 2x power half. Okay, so next step, you let dy dx equals to 0, then you simplify the term that you have here. Alright, so let's see what do we have. We'll be having 2 and 2 will be cancelled off. Then I will be having cos x, cos 2x on top, divided by sine 2x power half at the bottom, because of the power negative, right? Okay, then minus the term at the back is I'm having sine x bracket sine 2x power half. And now I try to solve this equation, and I need to group all the x to one side. And before that, I let dy dx goes to 0, then I try to solve them slowly. Okay, I bring this part to the left first. Okay, denominator very troublesome. I want to bring it up to the left. So when you're having power half multiplied with power half, then you have sine 2x. Then cos x cos 2x. Okay, then after that, how can you solve this equation? For me, I will change it become tangent first, where sine x sine 2x is equal divided by cos x cos 2x. You have be having equals to 1. Okay, then sine over cos is tangent. Sine x over cos x, you get tangent x. Sine 2x over cos 2x will be having tangent 2x. That equals to 1. Then how to continue simplify it? I want to expand the tangent 2x formula by using the double angle formula. So what is it? So it will be tangent 2x equals to 2 tangent x divided by 1 plus tangent square x. Okay, then this is provided in the formula booklet, but you will see that if let's say you memorized it earlier, right, for all this formula, for all this identity, when you are trying to solve the question, you automatically will have some idea, oh, I can actually apply this identity to solve it. Instead of you didn't memorize anything, then when you want to solve it now, you have to go and search for the formula, and then you might not have the idea how to apply them. Alright, so for me personally, I always strongly suggest that if you can, you try to memorize the identity for trigo. It will be quite helpful, I think. Alright, okay, so I want to apply this formula so that I'm having 2 tangent x divided by 1 minus tangent square x equals to 1. Again, the denominator very troublesome. I want to bring it to the other side. Then I multiply the numerator together. This is what I get eventually. Then 3 tangent square x equals to 1. Tangent x equals to plus minus 1 over sub 3. And they want the exact value of the a, right? Okay, so for me, I will only consider the answer for tangent x equals to positive 1 over square root 3. Because when I'm having tangent x equals to negative 1 over square root 3, the answer is in the fourth quadrant. And very obvious, my answer here is a positive value, right? So it should be in the first quadrant. Therefore, I only consider a positive value here. Tangent 1 over sub 3 is basically 30 degrees. So please convert the 30 degree into the radian, and it will be pi over 6. This is the x coordinate for the maximum point. It also means that the value of a is actually pi over 6. Right. This is what we have for part A. Then let's continue to part B. For part B, they are saying that the region bounded between x-axis and the curve is rotated through 2 pi, that means 360 degrees, about the x-axis. Find the exact volume, highlight the keyword exact, highlight the keyword volume of the solid generated. Okay, then to get the volume, the general formula is integration, yeah? So integrate pi y square dx. Okay? It's quite straightforward, the formula. Then let's have a look. Okay, I know that I want to have pi y square dx. What is my y square? What is your y? Your y is cos x sine 2x power half, right? So I want to have cos x, then sine 2x power half with a square outside. This is y, then square outside, then dx. When you want to apply integration to find the area or volume, you need to have the limit, lower and upper limit. So what is the lower limit basically? Alright, so where the area start is this one, because they want to find the volume generated by this whole area, right? So where the area start is 0. Where the area end is this point, where it is pi over 2. Okay? Therefore, that will be our lower and upper limit. So I'm having 0 to pi over 2. And this is how we set up the general formula for the volume first. After that, before I start the integration, I try to simplify everything and see what's the technique that I should use. Pi is a constant. I prefer to take it out usually. Then when I try to square the equation of the y, I will be having cos square x, then sine 2x dx. Alright, then I can't integrate this particular pattern. Then what am I going to do now is, I feels like I want to make the double angle sine 2x become single. Right. So what's the formula, double angle formula for sine 2x? Again, sine 2x is equals to 2 sine x cos x. Alright, then let's continue. It will be having 2 sine x, then cos x. Okay, further simplify it. You're having cos power 3x, then 2 sine x, right? Okay, then now let's have a look for this question and see how can we integrate them. All right. Yeah. So we actually didn't learn quite a lot of the integration technique, right? That involve this one. So maybe you have to think a little bit. But for me, I need to explain maybe one useful technique. We call it as substitution. Usually in our syllabus, right, or in the question, the substitution technique for integration, they are very kind. They generally will give you the substitution to be used in the question, where it actually saves a lot of our time and also the explanation in this technique, right? When they give you the substitution to be used, that is really straightforward question. You just apply it, then eventually you can get the answer very easily. But in real, okay, or maybe in the higher level paper, when you want to use the integration by using the substitution technique, you need to determine the correct substitution to be used on. So it won't be given. Okay? It won't be given. What are we going to do is that there are some simple formula for you to determine okay, what is a suitable substitution to be used in integration for substitution. Alright? Okay, in general, yeah, we actually did learn one substitution technique indirectly in the formula that we learned before in the syllabus. It is f prime x over fx. Basically, when you try to integrate f prime x over fx, right, we actually directly memorize the formula, which is ln fx plus c. We directly come to this part, right? And the theory behind is the substitution, basically. They are using the substitution of u equals to fx. When they let u equals to fx, then they substitute into the integration. Eventually they will get this as answer. Alright, just like you might see the explanation somewhere lah. Maybe when you try to study about this technique, you might see the explanation somewhere. So actually it involves the substitution technique. Okay, when you're having f prime x over fx, Therefore, this technique is also useful for some other integration that involve f prime x and also the fx one. Another example would be what we have here. If you are having f prime x and also with fx with power n, okay, you can see f prime x then with fx, right? You can also use the in substitution u equals to fx, then try to substitute it and try to solve it, and eventually you also get the answer. Okay, so this is why I want to try to introduce a little bit about the small technique here. Okay, therefore in our syllabus, this is the general formula, but actually the concept comes from substitution, u equals to fx. It will be also applicable for other type of f prime x and fx question, but you have to identify all this by yourself, right? And try to let u equals to fx, then apply the substitution method, you will get an answer eventually. Alright, then let's have a look for our question here. So for this question, if I try to rearrange it now, I'm having 2. I prefer to take out the constant all the while. Okay, then I want to put it into this form and see. I'm having sine x in front. Then I'm having cos x power 3. If you try to write become this pattern, right, you can see that it is very similar to what I show you here. Sine x maybe is similar to the f prime x of the cos x. Okay, then you're having a power n outside, right? Yeah, so to solve this integration, let's try to use the substitution. So I will let u equals to the function fx, which is cos x. Okay, then how to find the differentiation for cos x? Du dx will be equals to, the differential cos will have negative sign. Alright, then what is the du here? Du will be equals to negative sine x dx. Alright, yeah, so this is what I have, and I want to substitute into our equation later. Then for the substitution also, besides the equation, I also have to change the limits, remember? Right, so all these values here are the value of the x. So when x is equals to 0, what happened to my value of the u? So the u will become cos 0, and it will be equals to 1. Then when you let x equals to pi over 2, what will happen to your value of the u? U equals to cos, then pi over 2. And it is basically equals to 0. Okay? Yeah, and after I settle all this, I try to substitute what I got here into my equation. Okay, so I continue from this step, yeah? Right, so 2 pi is a constant. You just try to copy it. And now, how can I make it into the u? Okay, 0 is at the bottom limit, right? But when you substitute 0, you get a 1. Therefore, the 1 should be at the bottom now. Pi over 2 is on top, but when you substitute pi over 2, you get a 0. Therefore, the 0 should be on top. So don't change the sign, right? Don't change the location of your limit. Then now, I want you to have a look for this one, sine x dx. Where can you see sine x dx? Can you see sine x dx here? Okay, so sine x dx, you can replace it by using, I don't have negative, so the negative here, I will bring it to the other side. Okay, so sine x dx, I can replace it by using negative du. So I put it at the last part where it is negative du. So sine x and dx has been replaced, right, or substituted. Then what is the value? What is this one? Cos x power 3. Cos x is basically the u, so you're having u power 3. And now you can see that we have successfully changed our equation from x become the u. And we can start the integration now. Of course, the negative here is a constant, also I prefer to take it out. So you can see that I try to integrate u power 3 du, which is comparatively a much more simple integration. Okay, yeah, so u power 3 integrate, you will have u power 4 divided by the 4, put in the value 0 and 1. Again, I prefer to take out the constant every time before I substitute in the value. Then substitute 0 in, substitute 1 in, And you will see that basically you get pi over 2 as your final answer. And of course, I have to keep it in this pattern because it is the exact form of the answer. All right. So for this question, I'm using integration by substitution. But of course, you need to know how to decide the correct substitution by yourself, like in this case. Okay. All right. So this is the very last part. Okay, the last question of this video. Thank you very much for watching, and see you in the next video.